Welcome back to Workshopfriend and this video number 10 of renovating my small Adcock and Shipley 1A milling machine. Last video we began to work on the overarm support casting, and in this video I'm going to continue producing the 3 bores, which have to be to close tolerance, and also their relative spacing is going to be critical too. Before we get to that, last video I calculated the deflection of the overarm support bar. So in the comments section, Willem left, and forgive me if I haven't pronounced your name correctly, but Willem left a comment to the effect that perhaps bar sag is a factor that needs to be taken into account in addition to the cutting loads on the overarm support bar. So I thought I'd address that first and do a quick calculation to see if that is indeed a factor. So when we talk about bar sag, what actually are we referring to? Well, we're referring to the deflection due to gravity of structures such as this beam. So this is made of cast iron, about 2.5 inches diameter, and we can do a calculation based on the density and the size of the beam and the material properties, and we can work out how much that would deflect under gravity. The question is that significant? By the same token, the arbor itself is also subject to bar sag, and in fact we can pick that up. Here I'm just supporting the arbor, taking a proportion of its weight, and I can see the clock here moving. It's a very small amount, but it's moving. You might think it's due to the bearings, but I don't think it is. I think this is actually genuine bar sag. So you've got those two factors, meaning that a proportion of this will be carried by this arm, but also you have the mass and the weight of the support bracket which goes on the end here, which we're making, and this is the subject of this video. That's also contributing to a downward movement of this structure. So what we can do is we can calculate that and see if that is a significant number. So you've just seen the setup there. This is the overarm support, cast iron 2.5 inch diameter beam. This is the arbor, which is in fact a 1.25 inch arbor with the sleeves and the journal. And this is the bracket which we're making. We're going to be machining this today, continuing to machine it. This is made of cast iron. This is cast iron, this is steel. So we have a distributed load due to gravity along the length of that cast iron beam. And along the end, at the end here, right at the end of the beam, or nearly at the end, we have the weight of the bracket, the cast iron bracket, which is quite a lump. I think is around about 5 kilograms on the end here. And then we have a proportion of the weight of the arbor. And that's also acting right on the end of the beam. So we can do a calculation to see what that bar sag should be, what we would expect it to be. I'll go through this very quickly because it may not be of interest to all of you, but we do the calculation in 2 parts. First as a distributed load along a cantilevered beam. We've got the material properties and the dimensions, and we do the calculation and we come out at 0.004 millimeters, or 1/10 of a thou of downward movement, just due to the mass of the beam. And then we have the weight of the arbor and the weight of the bracket, and we can do a calculation for that. So the arbor weighs about 7.2 kilograms and the bracket weighs about 4.7 kilograms. So we have that downward force there, bringing the beam down by 0.019 millimeters, or 0.8 of a thou. And we can add the two effects together for small movements. So we come up with 0.023 millimeters, or 0.9 of a thou of downward movement. So that means that the end of the beam is going to drop around about 0.023 millimeters, or 0.9 of a thou, purely due to gravity, to bar sag. Now, by way of comparison, last video I did a calculation of the cutting forces. So the tangential cutting forces, as this is rotating, driving a cutter. The tangential cutting force, if we assume a cutting force around about 90 pounds or 400 newtons, that will result in a deflection here on the end. And we can put that in by way of comparison. That bar will move forward around about 0.047 millimeters or 1.9 thou. So you can see that for moderate cutting forces, not heavy cutting forces, but for moderate cutting forces, the lateral movement at the end of this is about twice the bar sag. Don't know if that's interesting, but I found it interesting. And it does show me that there's a certain degree of flexibility in the structure to cater for small malalignment. Not a lot, just a little. Not that I want to use that up. I want to get this dimensionally as close as possible so that when I push that over, it goes neatly over the top of this journal and everything is aligned. Anyway, we'll return to the machining and what I think most of you are interested in, which is the machining of this bracket. So here I'm continuing to rough out the larger of the three bores. There's quite a lot of material to take out here, and I will finish the roughing out 30 thou undersized. I was chatting with one of my nephews recently who watches this channel, and he told me for younger viewers metric units are really necessary. So for those of you who need to know, 30 thou is 3/4 of a millimeter. So I'm just checking how central the bore is in relation to the outer diameter of the casting. I can see that it's 1/64 of an inch closer to the top as compared with the bottom. Now 1/64 of an inch is 0.38 millimeters. So I'm just raising my table half of 0.38 millimeters. This is in fact a metric machine. So before I got to the final roughing cut, I wanted to make sure that the tramming was still correct, and I noticed it's quite a bit out. In fact, it's way out. So what's happened is that the casting has shifted, and I suspect that was during the early cuts when I was getting through the tough skin of the casting. What I was going to do originally was put another clamp on this side, but because I didn't have a stud of the right length, I left that off, and obviously that was a mistake. So what I'm going to do is make a proper stud like the others which I normally use out of 3/8 rod, which is 3/8 UNC in the T-nut, and it needs to be 6 inches long. Got my other clamping set up in now with this extra stud. I'm going to re-tram this and take a few more roughing cuts, and then I'm going to turn my attention to this end. I'll have to remove the clamp to get up here. I can replace it once I've relocated. I'm going to rough this end out as well. To get ready to pick up the center again, I've got my homemade DTI holder here, and I realized that I needed to change the link here for a shorter one so that it can get right up close to the work. So I've just made this, it just took me about 15 minutes, and incidentally it's a much better thickness as well. In my video when I made this, I realized that when the link is this long, that's just too thin, a bit too much flexibility there. So I'm probably going to remake this to this gauge. So now this fits in nicely. So the vertical alignment is as it was before, of course. so it's sitting nicely on the table just as it was last time. All I need to do now is adjust the horizontal alignment. So it looks like we've got to move the table that way by about 1.5 thou. I'll try that. That looks okay now. Tends to indicate to me this is slightly out of round, but I guess we've been doing roughing cuts and there may have been hard spots in the casting which has caused that. So I'm going to do another roughing cut and get a bit close to the final size. I've roughed this out now to within about 30 thou of the final size. I do hope that this wall section is not too thin. I have to admit it looks a bit thinner now than it did on the drawing, although we are looking at the thinnest section here because of the draft angle. It's actually broader across the center section. So what we need to do now is traverse the table 6 inches or approximately 6 inches for roughing out this end, the journal end. We need to move 6 inches, which is 152.4 millimeters. To get enough space to get past the boring head, I've got to remove this clamp. So I'll carefully remove that and then reinstall that, hopefully without disturbing the setting, for roughing this out. You can see from this shot and here that the high-speed steel tool is suffering a bit. It would have been much better to have used tungsten carbide, but I don't have that available at the moment. Later I used a much deeper cut to get through the skin, and you'll see that was much more successful. Here I'm now taking off 0.165 or 4.2 millimeters off the diameter in one go. And that was much more successful. I think that's also credit to the rigidity of the machine and also the boring head. So here I'm just aiming for a roughing cut, nothing critical on the size. I will be using a different setup to ensure correct spacing of the two centers. I've cleaned up the table, remounted the casting on the large boss here with 2 clamps and a jack on the end here, and I've aligned the center line of this boss and this boss with the axis of the machine. I've also aligned the center of the boring tool on the boss here on the vertical diameter approximately, and I can adjust that later on. What I'm going to do now is start boring this out. I have to do it in stages because the boring bar is actually too large to go through here, so I'll have to open it up and then gradually move through. And what I'll do is I'll clean this up minimally on this side, and as the diameter increases it will progress in this direction. The center line of this cotter is not actually on the center line of the boss, it's slightly displaced. And what I need to ensure is I don't take too much material from here, just enough to clean it up. If we move the cotter too far this way, then we won't have enough material on the drawbar, and if we move the cotter too far this way, then it won't perform its action properly and won't interfere with the other diameter enough. Here I overlooked something. I needed to raise the work to allow the boring head to get over the top of the table. So I've reinstalled the casting on the table, this time with a spacer underneath, which is the outer race of a ball bearing. So that enables me to bring the head over the top of the table, so I can bring the face of the head right up to the casting. That will enable me to go all the way through to bore this 1 1/8 inch diameter hole for the cotter. Now I'm using my DTI to pick up the previously machined center, which I've realigned, and what I want to do is make a slight adjustment in the vertical dimension just to bring the hole in the center of this outer cast surface. So that's just a 64th I need to change the height on. I can do that now, so I use the DTI to check that out, and then I've taken the dimensions, which I have here, the diameter of this bore, the rough machine bore, the diameter of this. I put a 1 inch diameter bar in there, and I measured the internal dimension from that bar to the rear face, and from that I was able to determine the two centers. So the centers are correct. All I need to do now is just open this out to 1 1/8 or 1.125 inches and just drop the table slightly to bring it into the center of the casting in the vertical dimension. Okay, I've reground the tool. This is ready for the final couple of cuts. This means I'm going to have to touch off on the previous diameter and take a light cut, measure it, and then I'll take one more cut and hopefully I can bring it to size. So I'm going to install this, and then we need to remove a total now of 9 thou to bring us to 1 1/8 inch diameter. I've removed one of the existing cotters from the head of the machine and just test this. Yep, that's fine. So in preparation for the now familiar setup, I've put the casting back on its other orientation, and I've squared up the rear face of the casting with the axis of the machine in preparation for picking up the bore and then taking the last few thou out of that to fit the bar up here. The reason I didn't bore this to size in the original setup was because I wanted to avoid any possibility of distortion. So that's why I roughed out all the holes and then came back to bring this to final size. So at this stage I really don't want to make a mistake, so I'm taking frequent measurements and light cuts to bring the bore to final size. We're currently 5 thou under 2.5 inches. I'm going to aim for 2.5 inches, not the 2.501. I'll aim for 2.5 and then see if that fits. And I can always open it out if I need to. I'm just double checking the end of the bar. And my internal calipers are telling me that's 1 thou under 2.5. So I've got a thou and a half to come off there. Also we've got our gauge, our plug gauge, which I made for this. So we'll take another 1.5 thou off there. I'm going to take another 1/2 thou off that. Hopefully that will be finally to size. Well, I reckon it should just about go on the end of that shaft now, so we'll give this a go. If any further metal remover is necessary, I'm going to probably do that some other way. I'm going to find it very difficult to get it back centered on this machine to take off 1/2 thou, so that's just not going to work, I don't think, but I'm 95% confident that this will go on now. Okay, let's get the boring bar out, and then we can fiddle around with this a bit more easily. We'll lock the cotter here so we've got a bit more purchase, and then we'll there we are. Great, that's what I was hoping for. Good. Okay, this needs to be deburred, so does the other side, and I need to make the cotter, and I need to bore this out on the center line of the arbor. Okay, that's what I was hoping for. That feels like a good fit to me. I think that's a good place to pause this video, and next video we will go ahead and machine this and make the cotter and hopefully paint it and finish it off. So thanks for joining me. If you've appreciated the video, do give me a thumbs up and consider subscribing if you've not done so already. I hope you'll join me again next video. Thank you.